you that you don't know me, I'm Dimitra Simeonidou. I'm professor in the Faculty of Engineering, and I'm the director of Smart Internet Lab. So Maria mentioned that 5G and beyond is going to be one of the themes for our conference. I'm going to talk about 6G and specifically creating the case for human-centric networks of the future, human-centric mobile networks of the future. And 6G is going to be, has started already, but it's going to be a big focus for Smart Internet Lab going forward in the next 5 years or so. So before we go to that, I have a slide just to give some context on who we are. So Smart Internet Lab is a research center at the University of Bristol within the Faculty of Engineering, and we have a community of 100+ academic and researchers associated and involved in our research. Plus, of course, we have many other associations across the university. We are founded by 3 research groups. Those are the Communication Systems and Networks Research Group, mainly looking at wireless communications. The High Performance Networks Research Group, working on optical and quantum networks, convergence and next generation internet. And the Photonics and Quantum Research Group, especially is contributing with photonic technologies for optical comms. We have combined expertise across optical, across wireless, IoT, and cloud technologies. And we're researching across enabling technologies, systems and networks, services and applications. So what is our USP? What is our unique offering in the research community, not only in the UK, but also internationally, is the fact that bringing this expertise together under a single umbrella, we're actually able to provide a holistic approach to end-to-end network design and optimization. We are having extensive expertise on hardware and software and co-design of those. And also we are very well known about real world deployments and large scale experimentation. And we are doing this, we are doing experimentation in the wild as a research tool, as part of our research methodology in order to address complexity in large scale systems, in end-to-end systems. So I'll stop here in the introduction of Smart Internet Lab, but I would like to give you a few examples of the work that we have done the last few years on a flavor of what we mean end-to-end networks. For instance, we have worked quite a lot on network convergence, multi-access convergence in particular across radio and fiber technologies, and also across compute, specifically mobile edge compute. So integration of MEC with network aids. And also we have done a lot of work on AI and processing at the edge. Our latest piece of work is looking at inferring actually user preferences for network service requests. So multi-access convergence is part of our end-to-end considerations. Another piece of work is on the mobile network backhaul. So we have done work on wireless backhaul, fiber, and now satellite backhaul technologies. So high performance, elastic, high bandwidth backhaul enable actually elastically to be able to choose backhaul services across different technology domains. We have worked on network slicing and service orchestration. We are one of the groups that actually start working on network slicing. I was thinking about this yesterday, about 7-8 years ago. I just found one of my presentations 8 years ago talking about network slicing for smart city application. So we're doing work on dynamic network slices, multi-tenancy, protection and prioritization of services. And also we are working on end-to-end intelligent service orchestration for multi-technology and multi-domain networks. But as part of our end-to-end consideration, it's always been the user and specifically the user experience. So we are involving use cases relevant both to the industry and public, relevant to the society, and we are developing methodologies for co-creation, how users can be involved in the innovation cycle. And I'm going to talk about this a little bit more later on. So why we are actually we are having this talk in this conference, and why at this point we are talking about 6G. First of all, research has already started on the next generation of mobile networks. That is the 6th generation of mobile networks. And there is already a lot of conversation around what are the technological breakthroughs and what are the challenges, and also what is the case from moving from 5G to 6G. And this is both a technological case, but also a commercial case. But for the first time, I see quite a lot of initiatives, industry as well, and network operators, they actually articulating as a driver for the next generation of mobile network societal drivers. So it is expected that 6G networks will drive, as usual, full convergence, but also is going to drive convergence across cyber and physical systems. And of course, like any generation of mobile networks, we are going to be asking for seamless connectivity and security. But some of the messages that are being articulated, they're talking about the need to provide networks that they're going to offer fully inclusive and equitable services to the society. So this is becoming a key consideration. Now, in my next bullet points, I just list some of the things that we hear across industry white papers, academic white papers around 6G. Of course, we are going to see new standards. And again, we are going to be talking about huge data rate. The numbers that I see is 1 terabit per second. And this is actually bit rate at the cell side, not at the user delivery side. We are talking again about extremely low latency, less than 0.1 millisecond, and location accuracy less than 1 centimeter. And latency and accuracy, as we are moving generations in mobile networks, is going to become more and more important. But this is your normal KPIs that you see every time as we're moving from one G to another G. There is also quite a lot of talk about supporting hyper-connected infrastructures of users and things. I was looking keynote yesterday, and on the question, what is 6G, is a network that is going to connect anything and everything. So this hyperconnectivity, and people are talking about Internet of Senses. How is it possible, actually, going back to that cyber-physical convergence, to actually create a digital infrastructure that is going to bring any kind of sensory information as part of the service offering? And when I'm talking about senses, I'm talking not propagating only sound and images, but also senses like smell, like touch, hot or cold, and so on. So there's a big vision there. Security by design and artificial intelligence also is going to play a major role within 6G, as it is energy efficiency and support for achieving net zero targets. I think we are going to see quite a lot of focus on net zero networking going forward, and requirement that actually our future mobile networks, they do better in terms of energy consumption and energy efficiency, but also enable and not net zero applications. So there are several emerging research topics that they need to be considered. But what are the key drivers? Why do we need to move at this point to a different generation? And I try to categorize here drivers coming from technology and drivers that coming in terms of requirements. And when I'm looking here technology, I'm not looking actually at technologies that they are considered core telecommunication technologies. So one, for instance, big requirement for evolution coming through automation, the need for automation and autonomy. So the need, for instance, for robots, autonomous systems, autonomous vehicles, unmanned machines to be actually being able to connect into our network. The second one is really the prevalence of clouded edge. We are talking increasingly about cloudification and edification of our networks. There is actually the need to develop these low energy technologies. So that is a technology that is going to drive our future networks. Security, the whole actually conversation, the big focus on telecoms and future telecoms at the moment is how we are going to make them more secure, AI, how we are going to use AI machine learning technologies to make our networks more intelligent, and also new ways of interaction with our networks. So AR, VR, of course, full immersion, holographic technologies for interaction, but also haptics. And so there are increasing requirements, the networks to connect not only to our mobile phone devices, but also to new ways, new devices for people to interact with services and the digital infrastructure itself. And then in terms of requirements, of course, limitless connectivity has been always a requirement. So seamless and resilient, we have seen it in any generation of networks, but also we start having this requirement of our services, our networks to be adaptive and also to be customized. Sustainability, I mentioned this before. So communications and networks as an enabler of the net zero, that is a key requirement. And it's an opportunity for us network researchers really to contribute to achieve these environmental targets that we need to achieve in the next 10 years or so. Trustworthiness, so trusted communications for computing computing for industry and society. So that's a big consideration that is coming always as part of the discussion. But there is something else that has been actually evolving through our conversations, especially during the pandemic. And this is how we are going to deliver a digitized physical world. So people are talking about this cyber-physical continuum. So we would like actually increasingly our digital experiences to be more realistic, more engaged, more inclusive, more fair. And this is where some of our work that we are doing is going to make a difference. I have to check my time at this point. So maybe I'm not going to talk through this slide in very detail. That shows you evolution of KPIs from where we are now to fully, for instance, deliver 5G by 2030, and then when we go to 6G networks. I'm going to make this slide, though, available, but just I would like to focus here that as we are going towards 6G, that security by design, which part of the 5G evolution, is very important. And I mentioned before about high bit rates, super low latency, extra, accurate location information and so on. But really where actually the big breakthrough, I believe, is going to happen as we are moving into the next generation, in that energy efficiency and alignment with net zero targets, and also the ability of these networks really to support massive machine type communication. So we are going to be looking at billion devices per square kilometer. And we have to start thinking what this means. And actually this requirement about this hyperconnectivity, that is what drives the other KPIs to some extent in terms of bit rate, in terms of latency, in terms of geolocation accuracy, but also the introduction of new services in terms of time and frequency synchronization as well. So let me summarize on the tech, because I didn't suppose to talk too much about tech, but here it goes, it always happens. So key technological focuses as we are going forward: hardware. Of course, hardware is always going to be important, but we are going to be moving increasingly from branded hardware to what we call white boxes. We are also going to be moving increasingly to generic hardware acceleration operations. Materials are important: radio, intelligent surfaces, fiber, quantum, new devices. So we need to innovate in terms of hardware. That work, that research should continue. Now, at the same time that research on hardware is going to be important, open source and open interfaces are actually becoming more important. So higher reliance to open source in terms of software, and higher reliance to open interfaces in terms of interoperability, and in terms of actually a more inclusive environment in terms of technology, new technology innovators and new vendors. I mentioned before about cloud. Our networks are going to be relying increasingly more on cloud. both for cost efficiency, but also in terms of horizontal scaling. And horizontal scaling is going to be very important. Sustainable, so energy efficiency and net zero is going to be a key consideration. That's why I put that in the center of that slide. Native security, so both cyber and quantum at application, service, and physical layers. We also need to see our networks continually evolving. And there are two types of evolution that we are looking. The one is fast evolution of network and software and application development. So our networks are going to start, and already started looking like a DevOps environment. So continuously upgrading our software stack and our APIs for application development. But also we should be looking at the infrastructure evolution. We cannot wait 10 years gap for going from one generation to the other. We have to have networks that are going to be able to self-synthesize, to be self-composable, a new kind of architectures that they are actually looking at distributed, disaggregated networks that are going to allow this to happen. And I left one thing which is very important, and this is integrated AI. So widespread of use of AI at all layers in order to build cognitive and data-driven networks. And all the other technologies, for instance, the cloudification, the continuous evolution, the leverage of open source, they are going to make use of AI tools in order to make it all work together and move forward to deliver intelligent services. I talked a lot about tech, and I didn't intend to, but when actually we are looking at our networks of the future, digital infrastructure and enabled technologies, it's a big story. And us as engineers, we are going to have these stories, our focus all the time, because that's our discipline. But what we learned from 5G, for instance, is that with 5G, for first time, we start linking our technology story with what vertical sectors need. We're talking about smart cities, we're talking about transport, we're talking about education, health, manufacturing. This now with 5G, that vertical sector requirements, they are becoming embedded into the way that we innovate, because we innovate not only for providing communication services, but we also innovate in order to actually support digital transformation into the sectors. This is going to continue. And I think this is something that we learned a lot as engineers in the last 5-10 years. But it's another thing, that pillar here that you see, people and economy. So digital infrastructure is not only about communications, it's not about digital transformation, it's how it changes and actually change our economy and change our society. So as part of our consideration should be how we can kick off, for instance, how we can support social innovation at the same time that we are driving digital innovation, how we can support, for instance, new models of participation, inclusion, integration is very important. I mentioned before the environment. Generally, civic renewal, digital infrastructure is going to be a very big part for this. I'm just being told that I have only 2 minutes, so I have to run very quickly. So if we are looking at this slide, there are 2 things that us as Smart Internet Lab, as University of Bristol, we are making interventions. The one is we are creating a methodology which actually we are driving co-creation of future digital infrastructure with end users. And then we are also creating a new facility where we are driving human-centric, we are driving experience-based innovation. And I'll go directly to these 2 facilities. So this is actually, we have created within our lab what we call a nomadic and deployable node. So this is a network, an end-to-end network in a box. And it's an open network architecture. It deploys completely new technologies coming, for instance, in the thinking around Open RAN. So having open, for instance, interfaces to develop applications on top of that through Open Run exposed APIs. We also use an open source packet core. I wouldn't go to too much detail of this, but this is a network that we can actually move and deploy, an end-to-end network in different circumstances. And we are working with communities here at Bristol. So we are working with smart communities. We are also working with our media sector through a new project called My World. And the whole idea is to offer actually this future network platform to sector and to a community so they can actually innovate in terms of services on top of this platform. And that actually service innovation from the sector of the community, of course, is going to inform our thinking in terms of delivery of the digital infrastructure. So this is the first path on co-creation that we are opening up. As I say, we are working within the next 3 months. We are going to place these platforms within 3 communities at Bristol. And also we are going to offer this into the media sector within My World project to see how, for instance, Future Network, they enable co-creation on new media formats, new media experiences. The second one, we are about to deliver a facility which we call the Reality Emulator. And what this facility is doing is really to drive experience-based innovation of future networks. So it's a digital twin, it's a sector agnostic digital twin. We are procuring it right now. I think is unique the way that we are thinking about this. So within our team, we experimented quite a lot of time on physical testbeds. And actually experimenting on physical testbeds has been very, very useful, for instance, for driving new technologies and driving sectors within the 5G. But physical testbeds are always bounded in terms of scale, are always bounded both in terms of user scale and infrastructure scale. However, they're giving us real-time data. So what we are doing at the moment, we are procuring this facility that is going to connect these physical testbeds to a virtual production facility. What is this? This is data centers, cloud infrastructure, data platform. So we are building quite an advanced data center that is able actually to handle processing, to handle data, but also at the same time is going to be able to host new technologies, for instance, new fiber, neuromorphic, or quantum devices. And the whole idea about this is to be able to do data hosting, data analysis, scaling, training, for instance, for AI machine learning models. Our software hardware co-design, generally we are thinking about 6G to be able actually to emulate different 6G scenarios, so to create these scenarios. Then we are having a digital twinning stage where we are creating a digital model of these scenarios, you know, having deployed the technology, having trained our AI machine learning models. But we don't stop here, because this is where most digital twins, they actually stop. We are providing services to an immersive experience space. So this is a multi-user, multi-purpose, interactive, multi-sensory facility that we are putting together, having users to experience the services here and now. And at this stage, we are working with a number of colleagues from behavioral science, from social science, that they understand actually user acceptance and user experience in a different way that we understand. And by analyzing, sometimes online, that user experience, we are able to actually create iterative scenarios, online chains, optimize our 6G, for instance, scenario creation, and then the service offering until the time that actually we get the user acceptance and experience that actually we would like to see out of the digital innovation intervention that we are making.
Dimitra, just any concluding?
I'm just concluding now, Maria. So we are building a case for 6G research here at Bristol in Smart Internet Lab. And that would involve design of future technologies, so network and service architecture at scale. We have done this for 5G, for 4G, for optical networks, and so on. We are at the path of co-creating with our end users. So with our nomadic node or deployable node, and also with the reality emulator, we are going to drive participatory experience-driven innovation. We also want really deeply to address security, net zero carbon emissions for telecoms, generally to see how responsible innovation would drive future networks, but also very much in our consideration, and that is in collaboration with other faculties, with other disciplines, is to address societal challenges, privacy, digital inclusion, diversity, and so on. And I will stop here